Good morning. Firstly, I thank ICCC, SA, and TISS organizers for inviting me for the brainstorming session on methane emission from landfill and waste. Myself, Dr. Naveen. Today, I am going to discuss on my research topic, that is methane emission and carbon sequestration potential from municipal solid waste landfill, India. Overview of my presentation goes like this. First, I will be discussing about introduction, and then I will try to highlight the landfill failures, then try to understand the scenario of Bangalore, then estimate the carbon stored in Mavalipura landfill, also quantifying the methane emission in Mavalipura landfill, then followed by conclusion. As we know, waste is a universal problem, and half of the world's population lives in the city, and in many developing regions, less than half of the solid waste is safely disposed of. At present, India holds the place in the third largest waste generator after China and USA. At present, 62 million tons of waste is generated. Plastic waste is 5.6 million. Biomedical waste is 0.175 million. Hazardous waste is 7.9 million. E-waste is 1.5 million tons. See, this is the, as per the Indian census, is 1 in 6 lives in unsanitary slum. This is the Mumbai slum. And if you calculate per day, per person is generating about 200 to 600 tons per day. And 43 million tons is collected, 11.9 million is treated, and 31 million is dumped in the landfill. Only 75 to 80% of municipal solid waste gets collected, and only 20 to 28% of waste is processed and treated. The waste will increase from 62 million tons to about 165 tons million in 2030. Similarly, if we predict for 2050, it will be 436 million tons. In case if city continues to dump this waste at the present rate without treatment, then we require 1,240 hectares of land per year. And projected generation of 165 million tons of waste by 2031, then it required a setting up of landfill for 20 years of 10 meters height and required a 66,000 of hectares of land. As we already aware, we are with increased population, we have scarcity of land also. So the best thing is we have to recycle the waste, utilize like a waste to wealth concept. So this is the photo of Ghaziapur landfill. As we know that Ghaziapur landfill opened in 1984 and reached its capacity in 2002 itself. But the city waste has kept on arriving each day in hundreds of trucks. About 2,000 to 3,000 tons of waste is dumped at the Ghaziapur each day. Unfortunately, on 18th 2018, hill has been collapsed because of heavy rain and two people have killed. After that, the dumping was banned. Meantime, the fire also sparked by the methane gas coming from this dump and regularly break out. Methane bleaching from the garbage can become even more deadly when it is mixed with atmosphere. So why it is coming? Because the reason is once the MSW is disposed in the Ghaziapur landfill, it undergo aerobic decomposition, which produce a very small amount of methane. Afterwards, the anaerobic condition prevails. Due to methogenic activity, the MSW emits methane for years, even if the landfill is closed. So that's why methane is emitted. So similarly, happen in the Dinor landfill. It is in Mumbai also, very oldest landfill. From 3 decades, waste is they are dumping. Here also, almost 5 to 6 people have died because of landfill failure. And another landfill, it is in Philippines. On July 10, 2022, because of heavy rainfall, again landfill failure has taken place and methane has been emitted. See, you can see here also 270 people have killed. And this is Greece also. It looks like it's in a completely closed, but without segregating, they have deposited, and with the liner, they have closed it, soil cover. But during the expansion of the landfill, again the failure has been taken place. This is the Colombia, and this is USA landfill and Indonesia landfill. You can see that every landfill which we have not maintained systematically without segregating, see the failure will take place. And coming to the Bangalore scenario, at present, Bangalore has grown significantly both in density as well as in population. This results in influence on the resource of the city. At present, Bangalore is generating almost 4,500 tons per day. And for existing capacity in Bangalore, we have only 2,400. We have 5 landfill, and that is KCDC, it's about 300 tons, Mavalipura 600 tons, Mandur 1000 tons, but it is not in operation at present, and Terraform is 1000 tons, MSG 500 tons, and the remaining 2100 tons is illegally dumped. This is the Mavalipura landfill site. It's about 46 acres. It is located in Elanka. The type of activity is windrow composting. Similarly, Mandur, it is located in Hoskote. It is 95 acres, and type of activities windrow composting and reuse. And Terraform, it's in a dump site, not landfill. It's about 130 acres. Here the vermicompost is doing. And KCDC is also a very small landfill. It is 15 acres. The type of composting is windrow. See, which I told you, two legally given by the Bruhat Bangalore Mahanagarapalike. This is the two quarry pits. It is located in Bingipura near Banargata and Jigini near Lakshmipura. It's 10 acres and this is 20 acres. See, this is an open quarry pit. Here, the methane is emitting. As we know that methane is regarded as one of the most important greenhouse gas because of its global warming potential, which is 28 times higher than the carbon dioxide over 100 years. See, initially, this is the BMP, it's about 226 square kilometers. This was initially, Bangalore was this much. That time, the waste used to collect and dump outskirt. The green points which we are calling is in dump sites. Then Bangalore has increased to 741 square kilometer. Then they start dumping outside. See, you can see this is the green dots is an dump site we have identified. Now Bangalore has grown to 1,258 square kilometer. It means that waste sites which were hardly in the periphery of the corporation limit of the Bangalore city are now in the developed zone of the greater Bangalore city. That's why we are facing this. And in 2012, the green city converted into garbage city. Because of this is the reason. And you can see this is the red color is called as an infrastructure, concrete. See this, it can see from the satellite image, the several structure has come near and around the earlier dump site. The structure building on this dump site can undergo distress due to high settlement and causes a failure due to low strength of dump space. This dump can also cause groundwater contamination due to leaching of waste by percolation of rainwater. For more information, you can go through this article. Similarly, this is I have opted Mavalipura as the my study area. This started in 2007. Ramki was operating this Mavalipura landfill. The capacity of landfill was 600 tons. However, Bruhat Bangalore Mahanagara, they were sending 1,000 tons per day due to mismanagement. They can't able to handle the waste systematically. Just they are collecting and they are dumping in the landfill. Within 3 years, this landfill has been closed. The villagers start protesting. They're telling that water has been contaminated because of the mismanagement. So in this context, I have taken this as my research area and try to understand uh, amount of carbon stored in the MSWPL in the landfill, also to estimate the energy and the power generation value using three independent methodologies like HEDL, IPCC, and LandGEM, and the further quantifying the methane gas production of Mavalipura site based on the data of waste disposal in the past and the future. This will reveal the efficiency of waste collection system. Also, this data which makes it possible to assess the available recoverable amount of methane as a fuel energy over a time. See, the total area of the landfill is 40 acres. In that, only 30 acres they have constructed. This is the landfill area where the waste has been dumped. So I have collected the two samples. I have by doing a boring. I have done the manual auger. Manual auger can be done at 3 meter. So at every half meter, I have collected the sample. You can see this. After bringing the sample to the laboratory, I have done air drying, then over drying, then I shredded the sample to less than 600 micron to conduct an experiment. And also, we have quantified the waste composition in Mamalipura landfill. I understood that the 62% is biodegradable waste and 9% is paper, leather, cardboard, and 4% is rubber, 1% is glass, 7% is plastic, 1% is metal, and 16% is other. It clearly shows that they have not practiced the segregation, just they have dumped as it is. See, as waste already contains 60 to 70% of water content. And definitely when moisture is there, degradation will take place and methane will be generated. See, here we have conducted the experiment of conducting the temperature, moisture content, pH, and TOC at every half meter. From this figure, it clearly sees that with increasing in the depth, with increasing in the depth, the temperature is also increasing because of anaerobic condition. The temperature near the top undergoes variation similar to the of seasonal temperature fluctuation, whereas the temperature go deeper depth, it follows a stable trend. See, initial decomposition of waste in the landfill occur aerobic condition. Then anaerobic condition prevails upon the depletion of oxygen at the bottom of the landfill. However, this trend shows some variation because of heterogeneity of the waste. Similarly, if you see the moisture content with increasing the depth, moisture is also increasing, pH is also increasing. This increasing in moisture may also contribute to increase in moisture content holding of capacity of MSW due to disintegration of particles after degradation. See, if you see the pH at the top, it was 8.3. As you go deeper and deeper, it's this 8.9. Similar trend we have seen in the carbon TOC also. At the 1 meter depth, it was 2.2. As you go deeper depth at 3 meter, it is 17.6. Similarly, we have estimated the methane. So I have collected the data from Bruhat Bangalore Mahanagaraparika. Bangalore is divided into 8 zones. East have 44 watts, West have 44 watts, South have 44 watts. Then Bommanalli 16 watts, Mahadevpura 17 watts, Rajarajeshwari Nagar 14 watts, Elanka 11 watts, and Dasralli 8 watts. See, then I try to quantify. This is east-west in one, and Bommanalli, Madhepura, Rajarajeshwari, Elanka, Dasralli. See, this is from this graph you can see that highest generating watt is east watt. It's about 900, and the lowest is Elanka. It's about 100 tons. See, zone-wise, I've done. Then I try to estimate the energy based on the theoretical approach. See, EDL approach is based on the total organic carbon present in the solid waste and the landfill gas generation. See, energy generation can be estimated by this equation. See, energy potential I got is 2,578 tons joules per year. And also, we have calculated the power, it is nearly 81 megawatt per year. Similarly, IPCC default method. This is based on the methane generation capacity was determined using the decomposable, degradable organic, and all carbon conversion to the methane emission with time was neglected in this method. So here, energy production for 1 year, adopting a gas collection of 80% if you're doing, we are getting 2,375 tons joules. And similarly, the power generated is about 75 tons. And this is the landfill. And this is based on the first order decomposition rate equation to estimate the annual emission over some time in specific landfill. And also this model assumes the 50% methane and carbon dioxide with additional trace of non-methane organic compound concentration and other air pollution pollutants. So this is the formula to estimate. See from this model, this is the total gas, this is the methane, carbon dioxide, this is non-methane. From this result, it clearly shows that from Maulipura landfill is ranging from 110,000 to 220,000 tons from the open landfill to closure. The detailed analysis, how I did everything, can be seen in from this article. And also we have quantified the electricity. We come to know that 63.13 megawatt can be generated. In 2050, the recoverable gas is sufficient to produce 12.2 megawatt, providing the notable power generation. This is because of methane has same chemical reaction as anaerobic digestion. Finally, I can conclude like this. According to EDEL methodology, the energy estimated of MSW is 2,578 tons joule, while according to the IPCC and LandGem methodology, energy emitted from the Mavalipura landfill is 2,375 ton joules and 1,998 ton joules. Also, the study estimates the maximum electricity generated from the landfill is 63.13 megawatt from the Mavalipura landfill. The study found that all the aforesaid LFG emission inventory used in this study shows the Mavalipura landfill site produce a considerable quantity of LFG into atmosphere. If you want to use this LFG directly for heating or indirectly for power generation, we need to collect, transport, and segregate of MSW. Otherwise, the green gas emission would continue to rise day by day. And finally, I leave the message like this. Composting organic waste is an eco-friendly alternative that enriches your garden and reduces the landfill emission. Thank you. For more information, you can go to this website.